Good afternoon. So before we get into our project today, I'm going to give a little introduction on myself. My name is Ben Noblock, and I'm a junior here at LSU. I'm currently majoring in construction management. I'm originally from Covington, Louisiana. And for our project today, we're going to be presenting a technology that's pushing the boundaries of traditional construction, and that technology is mesh mold. So how does this technology work? Well, nowadays, the construction industry is constantly seeking new ways to improve efficiency, reduce waste, and expand the boundaries of design. Traditional concrete formwork systems, while effective, often come with limitations, specifically when it comes to producing non-standard complex geometries. Because the construction industry is facing real challenges such as labor shortages, environmental impact, design limitations, and outdated methods that haven't changed much in decades, there's a growing need for smarter, more flexible, and more sustainable ways to build. So mesh mold, it is an innovative solution that addresses many of those challenges head on. It was developed through research collaborations between architects, engineers, and digital fabrication experts. This technology combines robotic fabrication with a unique hybrid material system that merges reinforcement and formwork into one. And this isn't just an upgrade to an old process. It's a whole new way of thinking about how we build. Mesh mold represents a shift toward automation, precision, and sustainability in construction. It challenges long-standing limitations and opens the door to designs that were previously too complex or expensive to bring to life. Exploring this topic shows what's possible when technology, design, and engineering come together. It's a great example of how innovation can reshape even the most established industries. What makes mesh mold interesting is that it feels like the kind of thing we'll look back on in 10 years and kind of just wonder how we ever built without it. And the sections that follow, we'll take a closer look at how the mesh mold works and the technology behind its fabrication, its advantages over conventional methods, and the potential impact it could have on the future of construction. And in these two pictures right here, we got a little example of how it works. You got the robotic machinery at the top right working on, the rebar and setting it all up. And let's get into the next one. So a little mesh mold overview. Instead of using separate reinforcement bars and bulky disposable formwork, mesh mold uses 3D printed steel mesh structures that serve both purposes simultaneously. And what makes mesh mold truly revolutionary is its ability to produce free-form structures that would be very difficult or even impossible to create using traditional methods. So this opens up a whole new world of architectural and structural possibilities, allowing for designs that are more customized, more efficient, and more sustainable. It is a system that merges two essential parts of concrete construction, formwork and reinforcement, into one. Normally, these are separate steps. You build temporary molds to shape the concrete and then place steel bars inside of it to reinforce it. But mesh mold combines both into a single prefabricated steel mesh that acts as the mold and the reinforcement. So what makes this possible is a robotic fabrication process developed through research at ETH Zurich in collaboration with Gramazio Kohler Research, the chair of concrete structures and bridge design, and other industrial partners like Payre GmbH and CK AG. The robots bend and weld steel rebar into custom 3D mesh structures, shapes that can be flat, curved, or even, doubly curved. These meshes are designed to meet international standards for reinforced concrete, and they're strong enough to act as permanent structural reinforcement. As you can see in the top right picture right there, you got a wall that's holding up the ceiling. So once the mesh is fabricated, it's transported to the construction site and assembled like a kit. Makes it a lot easier. Then a specifically developed formworkless concrete mixture is poured directly into the mesh using standard equipment. This eliminates the need for building and removing traditional molds, which, it saves time, materials, and labor. The technology is incredibly precise and efficient. The automation allows for continuous reinforcement in both directions, which not only meets structural needs, but also supports more complex architectural forms that were difficult or even impossible to build before. Mesh mold isn't just about building faster; it's about building smarter with less waste and more design freedom. And to ensure structural integrity, the system includes an automated design and optimization process that calculates the ideal placement, spacing, and size of the steel mesh elements. This means that the structure isn't just visually complex, it's also engineered to meet international standards for the concrete reinforcement. Like I said earlier, a little bit more on the specialized concrete mixture. Since there's no conventional mold holding the concrete in place, the team develops a mix that is highly flowable, but stable enough not to leak through the mesh. This concrete is poured directly into the mesh on site using standard equipment, so it doesn't require any new or complex machinery on a construction site. So because the mesh elements are prefabricated, sometimes they can be prefabricated off-site. Construction teams can assemble them like a modular kit, which makes it a lot easier than the traditional way. It speeds up the building process and minimizes disruption on site. It also opens the door for just-in-time delivery and better logistics planning. So to sum it up, for a little overview, mesh mold works through a fully digital pipeline from design to robotic fabrication to on-site assembly and concrete pouring. It merges material science, robotics, structural engineering into one seamless workflow, offering a high degree of customization while keeping costs and labor, relatively low. So mesh mold uses. So now we've explained what mesh mold is and how it works, kind of an overview. Let's talk about where it can actually be used and why it's exciting. One of the biggest strengths of mesh mold is its versatility. It allows for curved and complex shapes, kind of like how you can see in those pictures right here. You got a little circle and then you got a little part going out and another curve U shape. Yeah, I mean, it allows for curved and really complex shapes. Normally be difficult or nearly impossible to build. It opens up a lot of new possibilities for the architectural design. Instead of being limited to flat surfaces and simple form, architects can now explore more creative and fluid structures without really worrying about how they'll make it happen with traditional formwork. We're already seeing mesh mold used in experimental projects like research pavilions and unique architectural features where creativity and structural integrity both matter. But it's not just about, the flashy design. It has real potential in everyday construction too. For example, think about, just the curved walls, custom concrete elements, or even sound barriers and retaining walls. Things that need to be strong but don't necessarily fit into a basic rectangular mold. Another huge benefit is that the system works really well with off-site prefabrication. I know I've already said this, but it's just one of its main strengths. The mesh pieces can be built ahead of time and delivered to the site, which is perfect for modular construction or even like projects in cities where the space and time are tight, and it just allows things to go more seamlessly and better. Crews can assemble the mesh quickly, pour the concrete, move on without the mess and waste of the traditional framework. And beyond buildings, there's a lot of potential for infrastructure projects too, and especially in places where you need a lot of reinforced concrete, like bridges, tunnels, or transport hubs. The ability to adapt to non-standard shapes while cutting down on labor materials makes it a really attractive option. And then finally, there's a sustainability angle here that's worth mentioning. Because mesh mold eliminates disposable formwork and optimizes how much material is used, it helps reduce waste on site. Like I said, that's one of its biggest strengths. That's a big deal for an industry that's trying to become more environmentally responsible, just reducing waste and trying to be sustainable. So whether it's for bold architectural statements or practical construction needs, mesh mold has a wide range of uses, and it's setting the stage for a more flexible, efficient, and sustainable way to build. And it's just getting started. But yeah, I'm going to hand it off to John here.
How's it going? My name's John Patterson. I'm also a junior. I'm from the Mandeville area. Some internship and experience I've had over my time throughout college and just in the construction industry or with Grand Ethers Construction. I was kind of a field hand for them this past summer, and I started recently with an internship at Lemoyne, where we will be actually using mesh mold later in the job. and I'll get a firsthand experience with that and see how it really works. Plans for later in life, I like the Baton Rouge area, so I plan on living in Baton Rouge, Mandeville, Lafayette area, and just continue to grow and learn and get a full grasp of the construction industry and how it fully works in every aspect. Some of the things I'm going to be talking about before I dive right in, or some of the key points, or why the concrete mix matters, the key properties of the concrete, some advantages and disadvantages of mesh mold. And yeah, so I'm going to go with the next slide for me, Ben.
Yep.
So I'm gonna start off originally by I'm gonna start off firstly by saying one of the main things in the construction industry that doesn't get enough credit or attention is the concrete itself. Everyone focuses on in mesh mold. Everyone focuses on the robot in the mesh mold, the arm that bends and welds the steel mesh into shape. Without that, it can't happen. But one of the most important parts about mesh mold, though, is the concrete and how it's designed purposely to go with it. In traditional construction, you pour concrete into a mold, and that mold holds everything in place while the concrete sets. But in mesh mold, there's no mold. You've got this open steel cage mesh that's shaped into your final form, and the concrete is applied directly into it. This means that the concrete has to stay in place on its own without anything holding it together. So this isn't your average, sidewalk, slab pour mix. It's right when it comes out of the truck, you pour it in, and it's very setting. But what's unique about it though? What is unique about it though is that it's very strong, it's thick, and it'll hold its place initially right when it's set into the mesh. Uh, what makes the mix work? First off, the concrete has to be really thick, which is called the low slump. It can be it can be very watery, or if it drips, it will drip through the mesh, that's not what you want. But at the same time, it can't be too stiff or it won't flow into the spaces. There's something called thixotropic, I'm sorry. It is a word, is a weird word, but it actually is pretty simple. Thixotropic materials are stiff while sitting still, but they flow when you apply pressure. Think of it like ketchup bottle. Whenever you're just trying to squeeze it, nothing's coming out, or you turn it upside down, it won't come out. But as soon as you start to shake it or squeeze it, it'll all flow out. This is what we need here. Concrete that flows when it's being pumped or sprayed, but it firms right away and tightens up. Along with that, the mix uses fine aggregates, basically very small and sand particles, so it can move easily through the narrow spaces in the mesh. It also needs to be set quickly and gain strength fast so it can hold itself up as more layers are added to it. And obviously, as more layers will be added to it, it'll get stronger and its place will hold. But the first initial pour is honestly the biggest thing about it.
Next
And
slide.
another important part about it all is it has to bond really well to steel because the mesh stays in the final structure. The concrete needs to grip it tightly for the strength and durability of the fixture itself too. So later down the line, there will be no no mishaps. This all happens because you need very specific chemical additives. These help tweak the mix and make it behave just right. For example, super plasticizers help the concrete flow better without needing much water because too much water will weaken it also too. Stabilizers that makes that makes the consistency so the ingredients don't separate. And sometimes they'll also add fibers to help with crack resistance and improve strength. Also, every project is different. Kind of like how Ben said, you can be doing this in a big wide open warehouse, or you can also be doing it in a big city. It all just depends on the shape of the mesh and how the concrete is applied and what the structure needs to do. The mix might have to be adjusted. So there's no one perfect recipe. It all depends on the job you're at. I'm currently working at the LSP Crime Lab, and we're going to be doing mesh mold for a whole different on. We're gonna have a first floor and a second floor. And on the second floor, we have a whole different kind of mesh mold. So it all just depends on the where you need it, obviously the shape and the bend of it, and where you're doing it also. So I'm gonna give you some of the advantages of using mesh mold. Now that we've covered kind of how the concrete of the mesh mold works and is needed, I'm going to tell you some of the main reasons why it's even worth using. One of the biggest advantages of mesh mold is it combines two major construction steps into one. Normally, you need to build the formwork, then place the steel reinforcement inside of it. That takes time, labor, materials. With mesh mold, the robot prints the mesh in the exact shape that you need, and the mesh becomes both the mold and the reinforcement. So right there, you skip a whole step. And obviously, one of the main goals of construction is how to do everything most efficiently and fast, because obviously you want to try to get it done as fast so you can get your money and you can move on to the next job and your next goals down the line. It also makes it easier to build more complex and creative shapes. Since the mesh is made by a robot, you're not limited to any flat or straight walls. You can do bends, you can do like Ben showed, like a one with a circle in it, one with a complete U curve shape to it. And also, it's more sustainable. Traditional formwork, especially wood, often gets used once and thrown away. Mesh mold cuts down on the waste and because the process is automated, it can reduce the need for skilled labor site, especially in places where labor is limited and expensive. And another main point of construction too is how to do it the most efficiently and how to how to save as much money as you can and get out of there as fast as you can too. Some of the limitations of what holding people back from using mesh mold. One of the biggest limitations is the concrete mix itself. Like I said earlier, it has to be extremely precise. Even if it's a little too runny, if it leaks, if it's too stiff and it doesn't fill this mesh properly, it won't work. So there's a small margin for error whenever you do this, and there's more testing that needs to be tested, like that needs to be put in this field so it can be precise and be adaptable for everybody. Another one of the main issues is cost. The robot equipment is not cheap at all. You need software, hardware, and people know who to run it all. And that makes it harder for smaller companies to use. Then there's the scale of what mesh mold can do right now. So far, it's mostly been used for medium-sized walls and structures. We're not building skyscrapers with it just yet. Obviously, that's a goal later down the line as technology advances also too. But right now, it's just kind of doing the intermediate stuff. It's not too big, but not too small. And finally, there's a problem with the industry itself. The construction company is slow to change and they don't like change. A lot of companies are still stuck with traditional methods because they're familiar, they're cheaper, and they do not require extra training. And also, too, whenever you have a piece of equipment that's this caliber, you have to be able someone that's, fully knowledgeable and running it so that there is no mishaps and that it can just work at its full potential because you don't want, someone that's not qualified to depend on them to give you a structure, and then of course it doesn't work whenever you place it.
Yeah.
So I'm gonna wrap it up for you guys. Mesh mold is a super innovative system that uses robots and high performance concrete to build structures more efficiently and creative than ever before. It saves time, reduces waste, and gives designers way more freedom. But it's not something we'll see on every job site just quite yet. The concrete mix has to be fine-tuned, the tech is expensive, and the system still needs to prove itself on bigger projects. With this being said, the industry becomes an open tool to anyone. Mesh mold has the potential to really change the world and how we build, especially in areas where customization, sustainability, and digital design are priority.
How's it going? My name's Anthony Quibido. I'm a junior in construction management from Lafayette, Louisiana. I'll be finishing off this mesh mold presentation for y'all. Um, it's interesting, I think, about mesh molds, just to start, is that they're very structural and load bearing, which shows the real potential of this kind of technology in the modern architecture world. Um, And beyond that, researchers have looked into prefabricating mesh molds off-site and then transporting them for rapid assembly, which opens the door for modular construction where custom shapes can be created with robotic precision and installed efficiently. Um, but from a practical standpoint, mesh mold could be a game changer for infrastructure. Like for example, creating curved bridge supports or retaining wall with integrated reinforcement without wasting plywood or steel on formwork. So that's huge. It's a game changer in my opinion. Could also be used in urban designs, which think like sculptural facades or public installations with organic shapes that were previously too expensive or very time consuming to build. We've also brainstormed a couple new ideas, like using mesh mold and adaptive reuse. Uh, Picture like renovating a warehouse or an older building. For example, robots could move through this space and print custom mesh structures in real time, which could be used to fit walls to existing conditions without having to demolish everything or create new forms. And also, from an architectural design perspective, it offers a chance to build lightweight, curved walls that feel more like sculptural than structure. Um, it's a blend of like engineering and artistry, which is pretty exciting in a field that leans towards repetition and standardization. Uh, that's about all I got for application. And so in conclusion, to wrap everything up, mesh mold is more than just a new tool. It's a shift in how we think about building. It combines robotic automation, digital design, and advanced concrete technology into a single process. Um, what we get is not only precision, but we also get sustainability. And while we're also cutting out wasteful formwork and reducing material use and also minimizing manual labor. It's still in its early stages though, uh, but I think it's been doing well with what they've got and what they know about it. But most examples right now, are very experimental or research based, but the potential is real. It's there. And as robotic systems become more mobile and affordable, and concrete mixes become more advanced, um, we'll start seeing this move from research labs to a lot more active construction sites. And the bigger takeaway is that mesh mold helps us reimagine what's possible in construction. It's not just about efficiency, it's about giving designers and engineers more freedom to create. And so, really, I mean, just looking forward, this technology isn't just some weird idea. It's a foundation for a future where automated construction is the normal and where we're no longer held back by limitations of traditional formwork and labor intensive processes. And it's really all that we got here on Mesh Mold from the three of us. I'd like to shout out myself, Ben Noblock, and John Patterson. If anyone's got any questions, feel free to email or contact us however you fit necessary, and we will get back to you as soon as possible. Thank you.